This is the unit number 3, laws of motion. The first topic is force and inertia. The next one is the Newton's first law of motion. Then is the momentum. Then Newton's second law of motion, impulse. Newton's third law of motion, law of conservation of momentum and its applications. Then is the equilibrium of concurrent forces, static and kinetic friction, laws of friction, rolling friction, dynamics of circular motion, centripetal force and its applications, vehicle on a level circular road, vehicle on a banked road. Here we are taking the topic laws of motion, its basic concepts, important terms and formulae. Among that, the first one is the particle dynamics. It is the branch of mechanics in which we study the motion of particle. Not only the motion of particle, we also consider with reference to the cause of motion. And cause of motion is always the force. So in detail, we are talking about motion as well as the force that is responsible for that motion. Among that, the first law of motion that gives us the definition of force. Second law of motion that gives measure of force, and the third law of motion that tells force always exist in pairs. So these three laws are depicting the important properties of force. Then the second law of motion is the real law of motion. The inherent property of a material body is to remain at rest unless acted upon by the force is called inertia of rest. The property by virtue of which it tends to maintain its uniform motion is called inertia of motion. The property by the virtue of which body tends to maintain its direction of motion is called inertia of direction. Next is the total quantity of motion possessed by a moving body is called the momentum. Momentum is a vector quantity. It is denoted by small p. It is equal to the product of mass and velocity. M into V is the momentum of a body. Next is the force is product of mass and acceleration. The absolute units of force in CGS is dyne and SI unit is Newton. 1 Newton is equal to 10 power 5 dyne. When a large amount of force acts for a very short time, then we don't measure the force, rather we measure how much is the effect of force, and that effect of force is called the impulse. It is a product of force and time, the duration of time for which the force has been applied. It is a vector quantity. The next point is about impulse. It is the change in momentum of a body. Impulse is equal to the area under the force time graph. This direction we have taken the force, and in this direction time is being taken. Let this is a curve. Now in this curve we have taken, say, any strip for time t1 to t2. Now area under this strip, let it be a, b, c, d. So area of a, b, c, d. This is a force time graph. So this will be equal to the impulse for this time interval, and that time interval is t2 minus t1. So impulse that have been is equal to the area of this strip. The next is, if a man standing on a stationary lift, or if lift is moving with uniform velocity. See, in this case it is stationary. In the stationary there is no acceleration. If the lift is moving with uniform velocity, again the change in velocity is not there, so acceleration will be zero. Suppose this is a lift and this is a position of a body. The reaction is in upward direction and weight mg is in downward direction. For stationary, the a is 0, and for uniform velocity again a is 0. So in that case r will be equal to, the reaction on the body is equal to mg, and in other words the apparent weight is equal to the real weight of the body. Now if a lift is falling freely, then the man standing in lift experiences a condition called weightlessness. Here, the lift, it is acceleration due to gravity. So the net force is equal to the reaction plus the weight mg, and in this case the reaction will be equal to mg minus f. So F is equal to m into a, but a here is acceleration due to gravity, as body is falling under the acceleration due to gravity. So this is mg minus mg, and this comes out to be reaction on the body is 0. It means it is a free fall, weightlessness condition is there. Now the 13th point, if the lift accelerates in upward direction with constant acceleration a, then the apparent weight of man standing in the lift is greater than the true weight by an amount ma. See here, the reaction is in upward direction and the force with of the weight is in downward direction mg. Since the lift is accelerating in upward direction with acceleration a, therefore the force in upward direction is given by F equal to R minus mg, and R is equal to ma plus mg. So here we can see that true weight is mg and acceleration is a. So plus ma is being added when the body is moving in the upward direction in the lift, and the acceleration will be, acceleration acting on the body will be g plus a. Now the next condition is, if the lift accelerates in the downward direction with acceleration a, then the apparent weight of the man standing in the lift is less than the true weight. Let us see how it is so. This is the reaction R and the weight mg is acting in the downward direction. The total lift is moving in the downward direction with an acceleration a. So the net force is equal to mg minus R, the reaction. So R is equal to mg minus F. Putting the value of F, mass into acceleration, we will get m is into g minus a. It means whenever it is moving in the downward direction, the apparent weight of the man is less than the true weight. The next is, when two masses, say m1 and m2, are connected to the two ends of an extensible string passing over a smooth frictionless pulley, then the acceleration of masses is given by, acceleration is given by m1 minus m2 divided by m1 plus m2 into g, and the tension in the string T is given by 2m1 m2 divided by m1 plus m2 into g. According to the law of conservation of momentum, the total momentum of a system remains constant in absence of external force. Next is the law of conservation of momentum is derivable from both Newton's second law of motion as well as Newton's third law of motion. The next point is about the rocket. The net force acting on rocket is equal to the difference between the thrust and the weight of the rocket. The velocity of rocket at any time is given by V is equal to V naught plus VR log to the base E m naught upon m minus gt, where V naught is the initial speed, m naught is the initial mass, and VR is the relative velocity of the gases, and m is the mass at any time, say t. Next point is, the burnout speed of the rocket is given by Vb, it is equal to V naught plus Vr. V naught is the initial speed, Vr is the relative velocity of the gases, log to the base E m naught upon me, where me is the mass of the empty container. If the lines of action of force intersect at a common point, then the forces are said to be concurrent. Next is about the concurrent forces. They are said to be in equilibrium if there is no change in the state of rest or of uniform motion of a body on which the concurrent forces are acting on. Next is about the equilibrium. It is of two types. One is the translation equilibrium, another is the rotational equilibrium. As the word it is indicating, translation equilibrium is the one in which the vector sum of forces, this is we are talking about the vector sum of forces acting on the system is 0. On the other hand, in the rotational equilibrium, the vector sum of torques, because rotation is related with the axis of the rotation and the torque is one of them. So these should be the vector sum of the torques should be 0 acting on the system, and this is called the rotational equilibrium. Another point is about the frames of references. It is of two types. One is the inertial frame of reference and another is non-inertial frame of reference. The frame of reference in which Newton's laws of inertia holds good. It is called inertial frame of reference. If the frame of reference has an acceleration, it is called non-inertial frame of reference. The next point is all the fundamental laws which have been formulated with respect to inertial frame of reference. According to the Galilean invariance principle, the fundamental principle, the fundamental laws of physics are identical in all reference frames which move with the uniform velocity. Uniform velocity means there is no change in the acceleration, and that is with respect to one another. This is about the fundamental principle that goes with the Galilean invariance principle. This is the first question. The topic is Newton's laws of motion. A horizontal force 10 Newton is applied to a block A as shown in the figure. This is a block A and 10 Newton force is being applied on it. The mass of blocks A and B are 2 kg and 3 kg respectively. Along with 2 kg, there is another mass that is B. This is of 3 kg. The blocks slide over a frictionless surface. Because of this force, these two forces are sliding on the frictionless surface. The force exerted by block A on block B is how much force is being applied by this block A on block B. This is what we have to calculate. This question has come in the NEET 2024, and these are the options given for the question. Now, let us take the things that have been given in the numerical. The first thing is the horizontal force, that is 10 Newton, that is being applied on a block A. The mass of blocks A and B are 2 kg and 3 kg respectively, and we need to find out the force exerted by block A on B. Let FAB, it is the force applied by block A on B. Now, the formula for the force is mass into acceleration. So, mass we know, the mass of the body B is 3 kg because the force is being applied on it. It is 3 kg, but we are not knowing about the acceleration. So, this is what we need, then we can find out the force. Look, one thing, when the force is being applied on the two bodies taken together and the both bodies are sliding together, जब भी फोर्स हमारे पास दो बॉडीज के ऊपर लग रहा है और उनको वो मूव करा रहा है, तो वो एक हमारे पास कंबाइंड फोर्स जो है वो एक्सपीरियंस करती हैं, और इसलिए इनका मास भी कंबाइन हो जाएगा और एक ही एक्सेलरेशन जो ए एक्सपीरियंस करेगा वही बॉडी भी एक्सपीरियंस करेगी. तो यहां से हम लोग एक्सेलरेशन की वैल्यू फाइंड आउट कर सकते हैं. सिंस F is equal to ma and force applied, this is applied on both of the bodies, A और B दोनों बॉडीज पे लग रहा है, तो इसलिए मास जो है दोनों का 5 हो जाएगा 2 + 3, और एक्सेलरेशन जो है यहाँ से हमारे पास 2 मीटर पर सेकेंड स्क्वायर आएगी. इस फोर्स की वजह से जो एक्सेलरेशन जिसकी वजह से ये दोनों बॉडीज मूव कर रही हैं वो हमारे पास 2 मीटर पर सेकेंड स्क्वायर आ गई है. तो अब हम लोग वैल्यूज पुट करके जो हमारा डिजायर्ड रिजल्ट है उसको फाइंड आउट कर सकते हैं. इन प्लेस ऑफ एक्सेलरेशन वी हैव पुट द वैल्यू 2 मीटर पर सेकेंड स्क्वायर, और हमारा आंसर 6 न्यूटन आया है। इसका मतलब हमारा क्वेश्चन नंबर 1 जो है, द ऑप्शन सी इज करेक्ट एंड द आंसर फॉर द फर्स्ट इज द ऑप्शन सी, 6 न्यूटन. Now the question number 2. A truck is stationary and has a bob suspended by a light string in a frame attached to the truck. The truck suddenly moves to right with acceleration A. The pendulum will tilt and the options are given to us. This question is there on the page number 53 NCRT new one, and in the NEET Odisha it is in there 2020. So let us solve the question. According to this statement, the situation given to us is, this is a truck and a bob is attached to it. When this is given an acceleration, it is A, moves to the right. This is the right direction. So due to inertia, bob has a tendency to move in the left direction as the truck moves in horizontal right direction due to inertia of rest. Bob will move in left direction. So if we look at the bob, this is a stationary one, and when it moves to the left. Let theta is the angle made by the string with vertical when it is moving towards the left. If we look at the mass of this bob, then this, in this direction, it is when it is at stationary, it is mg, and with the acceleration, it is in the right direction. The bob will move in the left direction with the equal force mass into acceleration. If we look at this diagram, then we can have, let theta angle made by string while moving. The figure 1, this is figure 2, and from figure 2, what we have, tan theta is equal to ma by mg, or it is a by g. Theta is tan inverse of acceleration upon acceleration due to gravity, where theta is the angle of the bob string that is making with the vertical. So the option for this is the B option, and the answer is given by 2B. Now the third question. A particle moving with velocity v is acted by three forces shown in a vector triangle PQR. The velocity of particle will decrease, remain constant, change according to the smallest force QR, or increases. So this is the diagram given for the same, and this question has come in the NEET National 2019. So if you look at this figure, the forces have been given by the sides of triangle, and that is taken in order. It means they are in equilibrium. So first conclusion that we have drawn, since forces are given by the sides of a triangle taken in order, hence they are in equilibrium. And what does it mean? They are in equilibrium. The net force, that is force on PQ plus the force on QR plus the force on RP. This thing is equal to 0. Also, this F net can be given by mass into acceleration. And what the acceleration is? Change in velocity with respect to time, because in the question we have been given the about the velocity. So this, according to equation 1 and 2, m mass and change in velocity is equal to 0, or this thing is equal to 0. It means velocity is constant. Since velocity is constant, only then this differentiation with respect to time is 0. So the conclusion that we have drawn is it is moving the constant velocity. So if we look at the options, then option B will go with this, remains constant. So the answer for the third is option B. Now the question number 4. A player takes 0.1 second in catching a ball of mass 150 gram, moving with velocity of 20 meter per second. The force imparted by the ball on the hands of player is. So option A is 0.3 Newton, B 3 Newton, C 30 Newton, and D is 300 Newton. This question is on the page number 54 NCRT new, and it has come in All India PMT exam 2001. So let us see what we have to find out. The force imparted. If you remember the important concepts that we have discussed before these questions, the force imparted is equal to the rate of change of momentum. That is given by delta p, rate of change of momentum, and delta t is the rate of change of time. So force imparted is equal to mass into change in velocity and time. So mass is 150 gram. So this is 0.150 kg, and delta V is 20 minus 0, and this is 0.1. On solving, we get it as 30 Newton. So the force imparted is 30 newtons, and if we look at the options, it goes with the option C, and the answer for the fourth is option C. Now the question number 5. Physical independence of force is consequence of. The options are given: third law of motion, second law of motion, first law of motion, or all of these. This question is there in All India PMT 1991, and it is on the page number 51 of new NCRT. If you remember, before these questions, we have discussed the important concepts. There we had talked about all these laws of motion with respect to the force and their physical significance. And based on that, this question has been asked, where we are talking here about the physical independence of force. Since the first law of motion, the solution for this fifth, the first law of motion, it mentions a body remains in position of rest or motion unless it is disturbed by external force. Hence, the physical independence of force is a consequence of the first law of motion according to this concept, and the answer for the fifth is option C. First question on the topic, second, impulse and conservation of momentum. A ball of mass 0.15 kg is dropped from a height of 10 meter, strikes the ground and rebound to the same height. The magnitude of the impulse imparted to the ball is nearly, g is to be taken 10 meter per second square. Options are being given to us, and this question has come in NEET 2021. So let us see the solution of this. Mass is 0.15 kg. Height from it is dropped is 10 meter, and it again rebounds, and the magnitude of impulse. So impulse is equal to change in momentum, and impulse is equal to change in momentum m v2 minus v1. Now the body is dropped from a height of 10 meter. This is 10 meter. From here it is dropped, and again it rebounds to the same height. So if we take j cap as the direction that it is moving vertically downwards, and when it is going upwards, let minus j cap is the direction for that. Second thing, the velocity is equal to under root 2gh. So when it is moving downward, we are taking it with this direction, let it be v2, and when it is moving in the upward direction, at be 2gh with minus g. Now using these values in the above equation, impulse is given by mass 0.15 2gh j minus under root 2gh minus g. Now taking the magnitude of these unit vectors, it is under root 2gh. This is minus 1, and the minus 1, the magnitude of this j cap, this will become plus, and this is equal to this. So it is 2 into 0.15 into 2gh, 2g10 into 10. On solving, we get it 4.2 kg meter per second as the option for the impulse. And if we look at the options, option D goes with it. So the answer for the first is option B. Now the question number 2. An object flying in air with velocity 20 I cap plus 25 j cap minus 12 k cap suddenly breaks into two pieces whose masses are in the ratio 1:5. A body having some mass is moving with this velocity. In between, it has broken in the two pieces. They are having the ratio 1:5. The smaller mass flies off with a velocity 100 I plus 35 j plus 8 k cap. The velocity of larger piece will be, and the options are given to us. This question is there uh, on page number 58 NCRT new, and this is in the Odisha NEET 2019. So to solve the question, first thing is that if we consider, since ratio is given is 1:6, let the mass of body is 6m, and this is before the breakup. So at that time the velocity of 6m is 20I plus 25j minus 12k. Smaller mass is m, and the velocity and its velocity is 100I plus 35j plus 8k. Larger mass is higher after breakup of mass, smaller in the larger mass. Since according to the law of conservation of momentum, the velocity and the mass that will be contributed in momentum, so that momentum before collision is equal to momentum after collision. Momentum before collision is equal to momentum after collision. So we have 6m into 20I cap plus 25j cap minus 12k cap is equal to the value m 100I cap plus 35j cap plus 8k cap plus 5 into 5m into its velocity, say v. We need to find out the velocity, this v, that is being multiplied by the larger mass fm. So we have 5m v is equal to 120 I cap plus 150 j cap minus 72 k cap minus 100 I minus 35 j minus 8k. So velocity comes out to be equal to, so from here we conclude v is equal to 4I 23j minus 16. So this is the velocity of the larger mass. Now if we look at the options, our option number A goes with the answer 4I plus 23j minus 16k. So the answer for the second is option number A. In the question number 3, there is a rigid ball of mass m that strikes a rigid wall at 60° and gets reflected without loss of speed as shown in the figure. This is a body of ball, mass m, and speed v is striking the wall. So angle of incidence is 60 degrees. Since it is a perfect reflection, so angle of reflection is again 60 degrees without change in the speed. So this is also remaining v only. Now we have to find out the impulse imparted by the wall on the ball, and the options are being given to us. This question has come in the NEET 2016. So let us find out the solution for the same. Here, mass of ball is m, angle of incidence 60 degree, angle of reflection again it is 60 degree, initial speed v, and final speed also again is v. The impulse imparted by wall on the ball, this is given by change in momentum, that is final momentum minus initial momentum. Now, initial momentum is mv cos 60 degree, and final momentum mass remains the same, velocity there is no change, but there is change in direction. So it is given by minus mv cos 60 degree. So putting this value, the impact is equal to minus mv cos 60 minus mv cos 60. So this thing is equal to minus 2 mv cos 60 is 1 by 2. So here this minus sign is giving us the information that it is in opposite direction. Only direction has changed. There is no change in the magnitude. If we look at the magnitude of impact, impact magnitude is equal to mv, and it goes with the option A. So answer for the third is option A, m into v. Let us see the question number 4. An explosion breaks a rock into 3 parts in a horizontal plane. 2 of them go off at right angles to each other, and the first part of mass 1 kg moves with a speed of 12 meter per second, and the second part of the mass 2 kg moves with a 8 meter per second speed. If the third part flies with 4 meter per second, then its mass is. The options have been given to us, and this question has come in the NEET 2013. So let us start the solution of this question. If you see, there are 3 parts after the explosion, and 2 of them are right angle to each other. So we will have, according to law of conservation of momentum, we have considered let m1, v1 mass and velocity of first mass, m2, v2 mass and velocity of second mass, and m3, v3 mass and velocity of the third mass. So according to the law of conservation of momentum, m1 v1 plus m2 v2 plus m3 v3, this thing is 0, and we have defined m1 m2 and all up to m3 v3. So according to this, if you will see the mass, the first mass that have been mentioned 1 kg, and the velocity of that is 12 meter per second. Now, this thing, one more additional thing have been given to us, that two of them go off at right angles to each other. So we have considered these two masses are at right angles to each other. So to give them the direction, this is say in the x-axis and I cap is defining the direction. Next is the next one, mass is 2 kg, that is moving with 8 meter per second. So 2 into 8, this is mutually perpendicular. So I have denoted it with the J cap, plus m3v3 is the mass and the velocity of the third one. So this thing is equal to 0. m3v3 is equal to minus 12 I cap plus 16 J cap. Now we know the velocity of this v3 we know, but we are interested to find out m3. So there is the magnitude is required to find out the mass. So we will find out the magnitude of this. The magnitude of this, we won't be considering the negative part, 12 square plus 16 square. I put it in the form of magnitude. So this thing is equal to 144 plus 256 under root 400, that is 20. If we talk about the momentum of the third part, this is 20, and from here we have m3 is v3 is given to us 4 is equal to 20, or m3 is equal to 20 by 4, it is 5. So mass of this body comes out 5 kg. If we look at the option number B goes with it. So the answer for the fourth is option number B, 5 kg. Let us see the question number 5. A man of 50 kg mass is standing in a gravity-free space at a height 10 meter above the floor. He throws a stone of 0.5 kg mass downwards with a speed of 2 meter per second. When the stone reaches the floor, the distance of man above the floor will be. And these options are being given. This question has come in All India PMT 2010. So to solve this question, first see whatever the things have been given to us. According to the statement, a man, that this is the man, its mass is given 50 kg, is standing in a gravity-free space at a height of 10 meter. This is 10 meter above the floor. This is the floor. He throws a stone of 0.5 kg mass downward with a speed of 2 meter per second. Mass of stone is 0.5 kg and speed of stone is 2 meter per second. When the stone reaches the floor, the distance of man above the floor will be. The man is moving upward because he is in the gravity free space. So when he has thrown the stone, the time have been mentioned that when the stone reaches the floor, the distance above the floor will be. So man is moving in the upward direction. In the upward direction, how much distance he has traveled within the time when the stone reaches the floor. यहाँ पे जो मैन है वो एक ग्रेविटी फ्री स्पेस पर है और वो उस टाइम पे 10 मीटर है फ्लोर से, जब उसने एक स्टोन को नीचे इन द डाउनवर्ड डायरेक्शन नीचे फेंका है, जिसका मास जो है वो 0.5 kg है और स्पीड उसकी 2 मीटर पर सेकेंड है. क्योंकि वो ग्रेविटी फ्री स्पेस में है तो वो ऊपर की तरफ मूव कर रहा है और उसने जब जितने टाइम में स्टोन ने ग्राउंड को फ्लोर को टच किया उतने टाइम में उसने कितना डिस्टेंस ऊपर की तरफ मूव किया है, ये हमें फाइंड आउट करना है। तो डिस्टेंस फाइंड आउट करने के लिए वी विल बी नीडिंग द velocity and the time with which it is moving upward. So the velocity of this man has not been given, so we require velocity and time. कितनी velocity और कितना time है, इन दोनों को अगर हम फाइंड आउट कर लें तो हम डिस्टेंस फाइंड आउट कर सकते हैं। टाइम कैसे निकालेंगे? टाइम वो चाहिए हमें जिसमें स्टोन ने नीचे टच किया है फ्लोर को, तो टाइम हम स्टोन की इंफॉर्मेशन से निकाल लेंगे और स्पीड के लिए हम फाइंड आउट करेंगे, और स्पीड को फिर हम जब दो वैल्यूज को डालेंगे तो वी कैन कैलकुलेट दिस डिस्टेंस। नाउ वट एवर द थिंग्स हैव बीन गिवन, they have been mass and the speed. Whenever the mass and speed have been given, it is related with the momentum. So here also applying law of conservation of momentum, that is mass of man, speed of man plus mass of stone and speed of stone. This thing is equal to 0. Mass of man is 50 kg. Velocity we don't know. Mass of stone is 0.5 and the velocity is 2. So velocity of man is equal to 0.5 into 2 by 50, and this comes out and the value comes out 0.02. So we have calculated this velocity, only time is required, and time is how much? The time when the stone reaches the floor. So time within which stone reaches the floor is speed is equal to distance upon time, and here the time will be the distance it has covered to reach the floor is 10 meter, and time he has taken to reach with the speed is being given to us 2 meter per second, the speed of stone. So the value comes out 5 seconds. Now this is the time that stone has taken to reach the ground, and in this time how much the distance it has traveled we can calculate because we know the time and the velocity. Distance of man covered in upward direction. One more thing is there, this side it has come with the minus sign. This minus sign is showing they are in the opposite direction. The distance of man covered in opposite direction will be velocity of man into time. Velocity of man is 0.02 and the time taken is 5. So on solving we get it is 0.1 meter. So already it is at 10 meter from the floor and additional 0.1 meter in 5 seconds. So at present the man will be at 10 plus 0.1 meter. So the distance of man above the floor is 10 plus 0.1 meter. This comes out 10.1 meter. So if we look at the options, option number B goes with it, and the answer for the fifth part is option number B, that is 10.1 meter. Now we have taken the topic number 3, equilibrium of a particle and common forces in mechanics. In that, the first question is, a small block slides down on a smooth inclined plane starting from rest at time t equal to 0. Let Sn be the distance traveled by the block in time interval t equal to n minus 1 to t equal to n. Then the ratio of Sn to Sn plus 1 is, these are the options that have been given, and this question has come in the NEET 2021, and it is on the page number 58 of NCERT new. Now in this question we need Sn, distance traveled in nth second, and Sn plus 1, this is the distance traveled in n plus 1th second. We will take help of the uniform motion in kinematics. There we have done Sn, the distance covered in nth second, is equal to u plus a by 2, 2n minus 1. So we're making use of this formula. If we look at the things that have been given to us, this have been mentioned starting from rest. Starting from rest means u is 0. It is sliding down on an inclined plane, so we need to find out the acceleration. So this is the inclined plane, say at an angle theta. Here the block is being placed, and the block is moving according to the acceleration due to gravity. So let us resolve. This is sliding on this part. So one component is here and another component is in this direction. This is theta. This is g cos theta component, and this is g sin theta component. So here the movement is acceleration due to gravity, that is making the block to move, is its sine component. So we can have Sn is equal to 0 plus g sin theta over 2n minus 1. इसको हम इक्वेशन नंबर 1 मार्क कर लेते हैं. Now for Sn plus 1th distance, इसके लिए हमारा फॉर्मूला हो जाएगा Sn plus 1, 0 प्लस, क्योंकि इसमें भी इनिशियल वेलोसिटी 0 रहेगी, g sin थीटा बाई 2. अब टाइम जो है हमारा वो n plus 1th आ जाएगा, तो यहाँ पे हम 2n plus 1 minus 1. तो Sn plus 1 g sin theta over 2n plus 2 minus 1, और Sn plus 1 is g sin theta by 2. So this is 2n plus 1. Mark it as equation number 2. So Sn over Sn plus 1 is g sin theta over 2 into 2 g sin theta 2n plus g sin theta by 2, 2n minus 1. This is divided by g sin theta 2n plus 1 and 2. So these cancels out. We get it is the ratio 2n minus 1 over 2n plus 1. So if we look at the options, our result goes with the option number C. Hence, the answer for the first part is option number C is the answer for it. 2n minus 1 divided by 2n plus 1. Let us see the question number 2 of topic 3. Two bodies of masses 4 kg and 6 kg are tied to the ends of a massless string. The string passes over a pulley which is frictionless, that you can see in the diagram. The 4 kg and 6 kg mass, that is over a massless string over a pulley, that is frictionless. The acceleration of system in terms of acceleration due to gravity g is, this, if you remember, already we did it in the important terms and the formulae. I'm using that direct result for this, and that is acceleration is equal to m1 minus m2 over m1 plus m2 into g. डेरिवेशन में भी आपने ये इसको डिराइव किया है अपने थ्योरी में, और इम्पॉर्टेंट कंसेप्ट्स और फॉर्मूले में हम लोगों ने डायरेक्ट इसका फॉर्मूला लर्न किया है. तो इसको हम लोग एक्सेलरेशन जो है इन टर्म्स ऑफ ग्रेविटी इट विल बी 6 minus 4 over 6 plus 4 into g, and the value is 2 by 10 g. So it is g by 5. It's a very simple question based on the formula, and the option B goes with it. So the answer for the second is option B. Acceleration in terms of acceleration due to gravity should be A equal to G by 5. Now the question number 3. A block of mass M is placed on a smooth inclined wedge ABC. ABC is the wedge of inclination theta as shown in the figure. The wedge is given an acceleration A towards the right. This wedge ABC have been given acceleration towards the right. The relation between A and theta for block to remain stationary on the wedge. The block that is having the mass m should remain stationary over here. So we have to find out for that what is the relation between A and theta. ABC हमारे पास एक वेज है जिसके ऊपर मास m एक बॉडी का है, और वो जो ब्लॉक है वो स्लाइड ना करे, तो हमें ए और थीटा के बीच में रिलेशन फाइंड आउट करना है. जहां पर एक्सेलरेशन ए क्या है, दिस इज द एक्सेलरेशन विद विच ये ए बी सी वेज जो है राइट डायरेक्शन में एक्सेलरेशन ए इसको मूवमेंट दी है. तो इसको कैसे फाइंड आउट करेंगे, इस डायग्राम को दोबारा से आप देखें. दिस इज ए बी सी and this is the block m is kept here. This is theta, and this direction acceleration is being given. So this body's weight is acting in the mg downward direction, and the reaction of the body, this is r, and this angle is theta. Now this reaction of the body, if it is resolved in the components, this component is, since this angle is theta, so this is r cos theta component and this is r sin theta component. क्योंकि ये जो मास m है ये इस वेज के साथ अटैच्ड है, अगर वेज एक्सेलरेशन a राइट साइड मूव करेगा तो उसके साथ साथ मास जो है उसकी भी राइट डायरेक्शन में एक्सेलरेशन आएगी. लेकिन जो इसका स्यूडो फोर्स है, जो इनर्शियल फोर्स इस पे एक्ट करेगा, वो फिर लेफ्ट डायरेक्शन में आएगा. Pseudo force is inertial force, will act in left direction. So this will be mass into acceleration in this direction. तो ये हमारे पास डायग्राम है. Make sure this diagram must be clear to you. Again, I am explaining it. The weight mg is acting in the downward direction and the mass m of this block, so it is having this reaction on the just vertical to here. Now this angle is theta, angle of inclination, so this angle will again be theta. If we resolve this r, this component will be r cos theta and this will be r sin theta. Since this wedge is given acceleration on the right hand direction, so this mass will also experience the acceleration in the right hand direction, and because of that a pseudo force, that inertial force, will act, and that will just in the left direction, that is ma. Now what is being asked in the question? It is the question that the block remains stationary on the wedge. This block shouldn't slide. So we have to find out the relation between a and theta. Now look, this block won't move if the forces are balanced. If mg is balanced with r cos theta and r sin theta balances ma, then it is going to remain in the equilibrium. So we have to make the mass stationary on wedge. R sin theta should be equal to the pseudo force ma and r cos theta should balance mg. On dividing two of them, tan theta is equal to a by g, or we get acceleration is equal to tan theta into. Now if we look at the options, option number D goes with the result. So answer for the third is D option. If A is equal to G tan theta, in this case this block will remain stationary on this wedge. Now question number 4. Three blocks with masses m, 2m and 3m are connected by strings as shown in the figure. After an upward force F is applied on the block of mass m, the masses move upward at constant speed. What is the net force on the block of mass 2m? And the acceleration due to gravity is being given, that is to be taken g. Options are being given, and this question has come in NEET 2013. So just look at the statement again. There are three masses, they are connected together and they are having masses m, 2m and 3m. An upward force F is applied on the block of mass m. On mass m we have applied the force F in the upward direction at constant speed v. We have to find out the net force on the block 2m. So this is a quite concept based simple question. Since this velocity is constant and we know for constant velocity acceleration is 0 and net force on the block, either 2m or any of the block, will come only when there is an acceleration. Since acceleration is 0, so no net force will be there. I'll write down the explanation. Since the blocks are moving with constant speed v, for constant speed acceleration is 0. If acceleration is 0, then no net force is experienced by mass to man. Since acceleration is 0, so no net force, or the force will be 0. So option A is the correct answer, and the answer for the fourth is option A. Let us see the fifth question. A man weighs 80 kg. He stands on a weighing scale in a lift that is moving upward with a uniform acceleration of 5 meter per second square. What would be the reading on the scale? Taking G 10 meter per second square. Options are being given here, and this question has come in All India PMT 2003. To solve the question, just remember the basic concepts that we have learned. There we have done the when the lift is moving in the upward direction. Keeping those things in mind, we are going to do this question. This is a lift on which a man is there. So this is the upward reaction and the weight mg in the downward direction. The lift is moving in the upward direction with an acceleration of 5 meter per second square. This is the value of A. Since the lift is moving in upward direction, therefore what we need? Reading on scale. Therefore reading on scale will be R. So we have to find out the value of R here. Now the net force is equal to R minus mg. This net force is ma R minus mg, or R is equal to ma plus mg. This value of R will be A plus G. Now the mass is 80, acceleration is given 5, and acceleration due to gravity is to be taken 10 meter per second square. So the value is 80 into 15. So this value comes out to be equal to 44, 1, 2. So the reading, that is the value of R on the weighing scale, comes out 1200 Newton, and this goes with the option number B. So hence answer for the fifth is option B, 1200 Newton. Now the 13th point, if the lift accelerates in upward direction with constant acceleration A, then the apparent weight of man standing in the lift is greater than the true weight by an amount ma. See here, the reaction is in upward direction and the force of the weight is in downward direction mg. Since the lift is accelerating in upward direction with acceleration a, therefore the force in upward direction is given by F equal to R minus mg, and R is equal to ma plus mg. So here we can see that true weight is mg and acceleration is a. So plus ma is being added when the body is moving in the upward direction in the lift, and the acceleration will be, acceleration acting on the body will be G plus A.